few weeks ago I made these cord grips for these electrical connectors, and I ran out 2,000 of these in the end, and apparently they're fit for purpose and currently in use, but it turns out these connectors have to be put together in pairs, and the current workaround solution is just putting a cable tie around them, but it's leaving them a little bit crooked. So the aim is to get rid of the cable tie and replace it with a proper band that will hold these together a lot squarer than is currently possible. So it shouldn't be a terribly complicated thing to produce. What I'm thinking is if I make something with a taper on it and maybe a square section at the end, and then another square section in the middle like that, and then another tapered section with an end piece, and then obviously this is going to be a square, so from the side, from the front, what we're going to have is a hole there and a hole there, and this is where our connectors are going to push through, and then from the side they're going to sit in here. There is a very slight complication in the fact that there are a couple of lugs on these connectors, top and bottom, so I'm going to have to put a couple of little cutaways in here to allow for those. I'm not going to bother at the outsides because I'm figuring that by using these I can apply a bit of pressure to keep them together. So essentially what I'm going to do is make this out of 3 plates. So there will be a feed plate coming in from the back with just a square section pocketed out, and then on the front end I'm going to make this out of 2 plates, and I'm going to bolt those together and cut in with a taper cutter to make this front, and then on the central section I just need to put these slight cutaways to allow for these little tramline sections, and with a bit of luck these will just slide in the correct way up because these aren't symmetrical, so they're going to have to be in slightly different places, but with a bit of luck that will hold them together quite nicely. And if I get the spacing of this centre section correct, which I think is about 4mm, then these will fit together nice and snug and should be held in a pretty horizontal position rather than twisting as they are at the moment. So that's the plan. I've put together a few designs for the plates that I need to make. So this is going to be the bottom plate, which will screw into the mould, the mould base that I use, and there's the usual complement of bolt holes and separating points and some reference marks in the corner. And I'm going to flip this over and just counterbore some holes on the back, and then on top of that will be another plate which will act as a surround, and there will be 2 core plates in the middle which make these holes that I'm going to need, the square holes for pushing the plugs through. And I'm going to do this all in one. I'm going to cut this plate initially, drill some holes in the back, and then I'm going to bolt this onto the base plate and then cut through, creating the square surround, and then this slightly zigzaggy bit in the middle which will just leave these little notch holes. And then the third plate is going to be a fairly straightforward feed plate. Not a great deal of geometry on here, just a square pocket around to make the back of the little band, and a straight section in the middle which will be 4mm to keep these separate and nice and aligned. And then on the back of that obviously there needs to be a little feed hole where the material comes in. So it's not hugely complicated, just 3 plates of 6mm aluminium, 2 of which I'm going to bolt together so that when this is finished machining I should be able to lift this surround up and just leave these 2 core plates in situ, and then that surround will go back on for the moulding process, and the lid will come on top, and that will create our mould. So I'll get some aluminium sorted out, stick it on the milling machine and start creating this geometry that we need. and I think that's everything on the bottom plate. Well, on the top side anyway. So, yeah, got my magnet holes, got my reference marks, bolt holes, and they're going through. So, yeah, that is everything. So we'll whip this off. And then I've just got to drill through these 4 holes here, these 4 holes here, and then these 2 holes here, and then re-reference on the back so that we can counterbore these from the reverse. But, yeah, okay, only took about an hour. Okay, well here's the first 2 plates. I've added 4 magnet holes to these rather than the 2 that I drew on the diagram. Might need them, I might not. Everything else is there, and the counter bores on the back, and then this is the skirt plate, which again 4 magnet holes rather than the 2, and I've also added some magnet holes on the back. So this is the one that we're actually going to pocket around and cut through, hopefully leaving these 2 inserts here and then a detachable skirt. I've also prepared a few bolts. So where's my Allen keys? Here, let's just do a quick fit, and with a bit of luck, if I get this the right way up, that should bolt into there. If I can find the hole. In fact, what might be easier is fitting these guide pins first. So that one goes in there, that one goes in there, and then that should fit over there. Nice tight fit, and then these, with a bit of luck, will line up as well, and they do, which is good. So yeah, and they don't protrude, that's good. These I need to tighten, but yeah, that's the bottom section of this. So that's obviously not going to come apart because I've just bolted them together, and 3 more to add. But we'll put that back in the machine, reference off these points on the edge, and then come in and cut the geometry we need for the actual cavity. So yeah, that's coming together quite nice, and now just need to do the top plate, which is actually the easier of the 3. So this one's, again, I'll add 4 magnets for this, 2 guide pin holes, and that's it. I don't need anything on the back other than the feed point. So that one's literally 6 holes that I've got to drill, and then I'm going to have a go at pocketing that out. So I'll get set up on that one, and yeah, next stage. Right, well that's all of the holes I need on this side, so send that back to the origin. Now what I've got to do is, with a convenient 4mm slot drill, is just come in and take out the geometry on this side 3mm deep. The sun's going to be going down in a few minutes, so I might just park up and do that one tomorrow. I'll leave that there to remind me. Right, it seems it's happy at about 1/4 of a millimetre depth of cut, running at about 80 millimetres a minute, so it's taking 2 minutes to go around, and I don't know, best part of an hour I guess, but slow and steady. I don't want to break anything. Okay, that'll do for a finishing pass. And now I just need to drill a small feed hole in the centre, which I'm going to do with a 1.5mm twist drill. A little bit bigger than I would normally use, but it's going to be a little weak at the back here when I've put the feed bit in from the other side. So I'll try and reduce the pressure somewhat by using a slightly bigger gate than normal. Okay, that's about 0. Take this down, I don't know, 4mm, 5mm maybe. Okay, I've drilled these holes out and used them to re-reference the plate on the other side, so this is dead 0. And basically I'm going to come in 3mm with a 4mm twist drill, and that should take me down to give just a little bit of clearance above that hole that I've already drilled, and then we'll swap that out for a 10mm ball nose and come in about 2mm just to give us a slightly bigger landing area for where the feed point's going to come in. So if this is all correct, that should be central to the dot that I've already drilled on the other side, the 1.5mm feed. We'll check that in a moment. And yeah, that looks like it's central to that hole in the middle, so that's our feed. We'll be injecting the plastic through here and fill all the way around there, and now I've just got to cut the complementary part to this on the other 2 plates. Yeah, that looks pretty good. This one's on as well. Yeah, that's just dropping in the slot, so that's pretty accurate. Right, so all I've been doing here is just coming into these little reference marks that I make on the edges, and basically with the same 1mm cutter just dropping into the slots and adjusting the plate very slightly. And although a 1mm bit doesn't sound particularly large, when you look at it under a bit of magnifying lens, you can definitely see whether you're out by a few tens of microns. So it's a pretty reasonable technique for referencing the plates again. I've tried other methods, digital test style indicators. I did try putting little dots on the mould and picking them up with a needle point, but after you've moulded something a few times you tend to lose those dots, so I found the most reliable method is just to come in with a 1mm bit and just cut some reference slots, and then you can pretty accurately pick that up to within a few tens of microns, which is good enough for certainly a mould like this. So all we've got to do now is come in and go around this square section to make the frame, which will be done with a taper cutter. And although this is a 1/8 3.2mm at the tip, because I'm going in about 9mm, it's actually going to be a bit wider here, and I calculate that if I go in about 8mm, that will be a 4mm diameter, which will match with the 4mm slot we've cut on the other side. I may go a fraction deeper than that, maybe 8.5, It's not terribly critical, but we'll see how well it cuts and how long it takes. So I'll get that set up and we shall soldier on. Well, apart from gluing a few magnets to keep the plates together, that I think is it. So I've been drying a bit of polyurethane, warming the moulding machine up. So let's have a look. And yep. Okay, it needs a little bit of a clean, but not too bad. See if it runs. Well, we had a go at moulding it, but didn't quite get it to complete. As you can see, there's quite a lot of burning on this end here, and you can also see the marks on the tool. That's basically where it's trying to squeeze the air out, but because there's no venting on this tool at the moment, there's about 10 cubic centimetres of plastic going in, which means we've got to get 10 cubic centimetres of air, and as this compresses and heats up, it's basically burning at the edge there. So all I need to do is just cut a little channel down here and a very small vent, and I'll probably do the same at the other side, although it's not too bad on the other edge. Okay, I've had a couple of vents either side of this on the bottom of the skirt plate, which is where the burning seemed to be most significant. So I've got some channels going to the outside, which are 3mm wide and 0.5 mm deep, and the vents themselves are these really teeny tiny, almost scratches, which are 1mm wide and about 50 microns deep. So hardly significant really in the greater scheme of things, but that should just be enough to let the air pressure escape and give us a complete fill without the build-up of pressure there, which is burning the plastic. So we'll put that back in the machine and see if it's made any significant improvement. Well, it might have been a really teeny tiny vent, but it does seem to have solved the problem. We're now getting a nice clean moulding on both edges. I'm still getting a little tiny bit of contamination coming through from the previous material, but certainly comparing that to the horrible burning we were getting on the first run, a 50 micron vent on either edge is doing the job quite nicely. So now I just need to mould 500 of these. And here they all are, 500, and they've all come out pretty reasonably. So yeah, happy with that. And the ultimate check, do they actually fit? I did manage to break one of these playing around with it, but it still clicks back on. So getting these aligned correctly, that one should wiggle down there at a bit of a push, and then getting that one the right way up, that one should wiggle in there at a push. And there we go, another job finished.